All right, welcome everybody to the December 11th meeting of the Technical Advisory Council of the Confidential Computing Consortium. We are an open and collaborative community. Everybody's welcome to ask questions and join in the conversation today, just as you are welcome to contribute to any of our open source projects. We also abide by the Linux Foundation's antitrust policy, and you can read more about that at linuxfoundation.org/antitrust policy. The main agenda for today is hearing about Trustee, which might help us address some of the adoption hurdles that were identified in the IDC study that we commissioned. After that, we've got a few things to go over, and we'll try to get to as many as we can in the time that we have. But I've proposed a new TAC rule for 2026. The board wants us to focus on creating some more documents. So we've got an issue open to start drafting those. And then the minutes, I know, are never super exciting for people to go in and review, but I could use some help fixing those up from last session. Were there any other agenda topics that people were hoping to discuss today? Okay, well, with that, let's check in and see how we are doing with attendance today. Do we have anybody from AMD on? Okay, I don't see any AMD. I think I saw Paul. Yes, thanks for joining, Paul. And I see both Keith and Renee. I think the attendee list is jumping around on me. Anyone from Huawei? Nope. Do we have Scott or Simon?
Yes, you do.
Awesome. Thanks for joining, Scott.
Yes, sir.
Henry or Kevin? No Henry or Kevin. Do we have Alec?
Not at this moment. Usually he joins in the middle of the meeting or a few minutes later, I should say.
Sure. Thank you. I am almost certainly here. I see Yash. Thanks for joining, Yash. Mingshen, thank you for joining. And do we have anybody from Shielded Technologies? Nope.
Unfortunately not.
So we'll get to this in the latter part of the meeting, but starting next year, we're going to record attendance a little bit more closely. And then for purposes of quorum, if we have people who cannot regularly attend the meeting, they won't be included in the calculation for quorum so that we won't be blocked on making forward progress.
On that, Dan, I'm just curious, the quorum says it's a flat 5, like not a percentage. What does it matter if we count people that aren't here?
Well, it's supposed to be, I think, half, so that calculation.
Oh, okay. The 5 might be reduced. Okay.
Right.
Gotcha. Thanks.
All right. And now, if you're new to the community, we want you to feel comfortable to join in, and sometimes it helps to introduce yourself so you feel like you're able to jump into the conversation. So feel free to jump off of mute and let us know how you prefer to be addressed, where you're joining from, and what your interest in confidential computing is.
Hi, I'm Renee Kolga from Google Cloud. I actually work with Keith as well on our confidential computing team and confidential space and attestation. So yeah, definitely excited to be part of the community.
Great. Wonderful to have you here, Renee.
Based out of the Bay Area.
Thank you. Okay, well, if other people would like to introduce themselves as they go on, you're certainly welcome to do that. Welcome to jump into the conversation without doing that too. Last time we were talking about 2026 things, so the we discussed some of the recent publications and what that portended for us for clarifications that we want to start putting out, and that will be in the form of new guidance documents that we author in 2026. We also touched on the budget, and that brings us up to today. So we went through the annual election period for the TAC. Nobody decided to get rid of me, so you have to listen to me again. Ijlal is on vacation, I think, for the rest of the year, but she will be joining to help co-chair the meeting. And then each of you will also be able to help co-chair a meeting. We are going to do what we kind of started during the second half of the year here, which is going on a rotating schedule. So we've got pretty much a blank slate looking at 2026. For 2025, you can kind of see this rotating thing that we had started to do. That ran into a little bit of trouble because of people switching roles just as we were doing this. So we didn't get it into effect as well as we would have liked. But you can see the general idea is that each session, I'd like one of you to help join us to craft the agenda and be part of developing what we do. And that also helps provide some planning if myself or Ijlal becomes unavailable to run the meetings for whatever reason. This will be our last meeting of the year, but that doesn't mean that our work is done. We still have, for many of us, more business days left, and we've got some open topics that I'm hoping people can contribute to in the GitHub issues in particular. But a early happy Hanukkah and Merry Christmas to those of you celebrating holidays. Ramadan isn't until I think February yet, so more holidays out there. Oops. Other thing that transpired since the last meeting is the board finally decided on a budget, and that budget is smaller. The CCC as a whole had been doing deficit spending for the last few years in order to try to really, accelerate what we had in the market or highly advertise what we have in the market. The budget is now a balanced budget, and that means that we did not get some of the budget that we asked for to support those projects with those new project grants. So one of the first things that we'll want to do at the beginning of the year is come back and take a look at what we can do there. I'm working with Rian right now to see what we can do to kind of reallocate money from areas that we haven't really spent against historically, and try to use that money to keep those funding proposals intact if we can. Any questions on any of that?
No questions, but so Dan had asked me to create a year-end review for the TAC. So I will send that out to the TAC mailing list, let's say early next week, either tomorrow or early next week. We actually got a lot of our OKRs achieved. So there is a 2025 OKR document, and we had a very active first half of the year. There were like reviews and tech talks almost every week. The second half in Q4, there was less engagement, but still, when you look at the whole year, we actually got a lot done. And I just wanted to thank, all of you who presented, contributed to that. We got the TWI SIG off the ground. We voted on project proposals as well. So thank you, everyone, for those who contributed and those who worked on it.
Yes, thanks a lot, Yash, for bringing that to our attention. I know that I'm always kind of focused on what we're not getting done and what we want to get done in the future, but it's very important to recognize we've actually accomplished some good stuff this year. So looking forward to that report. And I know it takes a good bit of work to kind of dig through a year's worth of material to extract all that goodness. Mona.
Hey Dan, since you brought up this issue, as you know, in the issue I was a little bit concerned on what criteria people had used to pick to vote the top projects, and now sounds like you have to revisit anyway, right? So it'll be good to know the criteria, right? Because at least to me that wasn't clear. It seemed like there were some discussions in the meetings, and I actually didn't attend those meetings. So yeah, so it'll be good to know maybe when you are looking at revisiting this, maybe we at that point, because if you had the criteria, you can actually make this determination even better, right? Which why now pick one instead of the two? But yeah, and then if you want help with that, maybe I can help next year. I mean, for this year, whatever criteria was used, and you will use that to evaluate which one comes first, correct? And
Right.
also, yeah. And also just so I'm not at Intel anymore, but I'm still with the Grameen project. Yeah.
Well, I'm glad for the Grameen project that you're still attached to it. The criteria that we used was quite subjective. I'm certainly game for anybody coming up with a more objective criteria. And we can probably talk about that during the January 8th meeting. Though it would be great to have criteria proposals either attached to that original funding issue or maybe create a new funding issue since I closed the previous one.
Okay. Thanks.
All right. Anything else on announcements? All right. So this is what we're going to talk about today. We're going to talk about trustee momentarily, and then the other items that I touched on during the agenda announcements. So trustee is part of the CNCF Confidential Containers project, but it is a fairly loosely coupled service or collection of services. So it might be of independent use outside of COCO, but I wanted to kind of give a little bit of context there. And I have asked my friend and colleague Ding Ma to come in and present because in looking at the IDC report on the key adoption hurdles, it kind of seemed like attestation was a pretty big thing on there. And this trustee system helps, or rather this trustee system provides a lot of functionality there. And so I am going to stop sharing so that I can turn the show over to Ding. Keith, you wanted
Before
to...
you hand it over, just as a newly coming back to the TAC, the slide deck you're presenting, for slides like that, it'd be really useful to be clicking the links. Where can we discover that before the meeting or during the meeting? Is that somewhere we can find?
Yeah, sorry. Usually I try to drop things into chat when I do have the links. Probably next year we'll do a better job of circulating the link to the slides beforehand. I will admit that a lot of times these slides are prepared in the moments before.
Sure. No, I understand that. One thing we use slides extensively at Google, as you might guess. Having a drive folder where those things exist might make it so you don't have to actively push them and people can go pull them.
Yeah, that's great. And so maybe, Renu, one thing that we can start doing in 2026 is when you prepare that first deck for us, you can drop the link for it into the TAC channel, and we'll just assume until otherwise that people won't abuse that edit capability.
Makes sense, definitely.
Okay, so returning to what we're about to do with trustee, Ding, feel free to share as you're able there. Ding is from Alibaba Cloud. He's a senior development engineer. He works on confidential computing and software supply chain security, and he's one of the main developers behind Trusty. I know Ding from the Coco community, but I've never met him in person. I have slightly suspected that he might just be an advanced AI. I don't think he sleeps. I just see code and PR reviews. So good chance he is a bot, but we'll hear his text-to-speech rendition today then, if that's the case.
Oh yeah, thanks, Dan. So can you see my screen?
Yes.
Yeah, great. So, okay, let me start. So, hello everyone. I'm Ding from Computational Containers community, and now I'm working for Alibaba Cloud. So, first of all, much thanks to Dan for inviting me to share our work with you today. It is also really nice to see many leading contributors in computational computing, and very glad to have a chance to do the presentation about the trustee. So trustee is a general purpose attestation verifier and a broker for relying party services. So what I want to focus on is how trustee can act as a common attestation and key broker layer that sits alongside existing CCC projects and vendor services. And we hope that people will know more about it and contributing to it and personally standardize its protocol. So let me start. And this is a motivation. And in computational computing, we all know attestation is essential, but in practice, attestation is a hurdle. And this slide shows the survey result from CCC folks about the key challenges or risks in adopting computational computing. And if you look at the top bar, the number one concern for more than 80% of respondents is validating attestation chains of trust. So the thing people worry about most is not just that my T exists, but also can actually validate the full attestation chain end to end in a way understand and trust. So right below that, you can see several related challenges that many of us will recognize. The first is still seen as an initial technology with limited proof points, and there's a lack of skilled personnel who really understand all the details of attestation, TEs, and policy. And there are inconsistent approaches from public cloud providers, which creates a real risk of vendor lock-in. And there's a lack of standardization, especially in how you actually consume attestation results. And further down, you see concerns around using key lifecycle management in a computational computing context. So taken together, this chart basically says attestation, standardization, and key management are right at the center of people's concerns. And trustee is aiming exactly at this intersection. And first, to make attestation validation more uniform, to reduce the inconsistencies across clouds and TEs, and provide a standard way to plug attestation into K and secret lifecycle management. And let's see. So the question for us is, what would it take to address this in a way that works across vendors and clouds? That's what Trustee is trying to do. And on the left, you can see a few key properties that Trustee have. The first is Trustee provides a common attestation abstraction and protocol. Instead, every project talking to every cloud-specific verifier in a different way. Workloads can talk to Trustee in a uniform way. And it also collaborates with CCC projects like Verizon and VerTE. And we don't replace those verifiers. We consume them and turn their results into a common format that policies can use. And the trustee can support vendor verifiers and even non-CC usage like the TPM platforms. So you can mix TEs from different vendors and still have a single broker layer, and the same protocol can also serve non-TE workloads where you still want strong policy before releasing keys. And it may help fulfill CCC or the WIMS workload identity goals by mapping evidence and measurements into a stable workload identities, which I will come back to later. And finally, it is customer driven. And many of these capabilities came directly from people who are feeling the pain you see quantified in the chart. And before I go deeper into Trustee itself, I want to briefly mention the community I'm representing here, confidential containers. And the confidential containers was accepted into CNCF as a sandbox project in March 2022. And our focus is very much on cloud native use cases, is to running containers inside TEs, is to integrate with Kubernetes and the broader cloud native ecosystem, and make confidential computing consumable for large-scale workloads. And TrustE actually originated from the context. As we tried to run containers confidentially, we quickly hit the attestation and key management hurdles you saw in the survey. And we needed a way to standardize attestation flows and key broking across different clouds and TEs. So TrustE started as an effort inside the confidential containers ecosystem, and then grow into a more general project with a broader set of adopters. And let's see the TrustE architecture. And this on the left, we have a confidential VM, obviously a CVM with a attestation agent running inside it. This agent is responsible for collecting evidence from the TE and sending it out when the workload needs to access a sensitive resource. And in the middle is a key broker service, obviously the KBS. And this is a central piece that every workload talks to. On top of it, you see a resource policies. And these policies describe which workloads are allowed to access which resources under which conditions. On the right, you can see the attestation service, and we usually call it AS. And this is where the actual verification of evidence happens. The AS checks the endorsements of the evidence, and it also provides fine-grained check against the evidence fields driven by attestation policies. The attestation policy defines what the field should be like, and it supports to query reference values from the reference value provider service at runtime. The reference value provider service we usually see shorted as RVPS supplies the reference values to the ES. And finally, at the bottom, you can see the KMS. The KMS is one example of the relying party that actually holds the keys or other sensitive materials that the workloads want to use. So structurally, TrustE gives us a AS that knows how to verify evidence using reference values and attestation policies, and a KBS that makes policy decisions and talk to reliant parties like KMS, and a clean separation between attestation logic and resource access logic. And we bring some more boxes into the picture, and let's see end-to-end flow and how TrustE interacts with other services. So the first one, the CVM wants to use a resource, for example, a key, and the attestation agent inside the CVM sends the attestation evidence to the key broker service. And the KBS doesn't try to verify this evidence itself. Instead, it forwards the evidence to the attestation service on the right. And the attestation service consults the vendor-specific services to verify the endorsement. And it also consults attestation policies about how to interpret this evidence and what the fields should be like. And it also consults the reference value provider service and about the reference values. And using those, it verifies the evidence and produces an attestation result. The attestation result is expressed in formats like EAR, obviously the AR4SI. That attestation result is sent back to the key broker service. The KBS combines this result with its resource policies to decide whether the requesting workload is trusted enough to get the resource it is asking for. This is a whole end-to-end flow. And this picture shows the
real quick, if you don't mind stepping back one slide.
Okay.
So I know this is something that I think I knew the answer to at some point, but I'm having a hard time spinning at my brain this morning. So with Trustee, is the key broker service kind of fundamental to the mission of Trustee, or could you use this attestation service directly from the attestation agent? Or more directly, could you be getting back the attestation result, the EAR token, without involving the key broker, if that's what your use case desired?
Yes, we can.
Okay, great.
I think maybe one other clarification is that name key broker service is sort of historical, because the first use case that was there for Coco was encrypted containers, and so you absolutely needed a key to go decrypt the container image. Over time, this is now a general purpose resource broker, and so it stands as a sort of facade or something in front of other services.
Thanks.
Okay.
Okay, so let's go to this slide. And this is a REST reminder. And I think we are all familiar with this model. So what I want to see is that Trustee is intentionally aligned with the REST concepts. And we are not inventing a new conceptual model. We are implementing REST in a way that's convenient for cloud-native workloads. So this page shows how the Trustee architecture maps onto REST. And we can see the attestation agent in the CVM is a attester, and the attestation service acts as a verifier. The key broker service acts as a relying party, and the reference value provider service supplies the reference values, And we have explicit attestation policies and resource policies. So if you think in REST terms, Trustee is essentially a relying party plus verifier plus reference value provider packaged as a reusable service with a standard way for workloads to talk to it. And let's recap the architecture of Trustee, and we will move the boxes on the next page. So, okay, we move some boxes. Let's talk about the deployment versatility. And this diagram shows a basic deployment of Trustee, and we can see it includes AA, KBS, AS, and RVPS together with policies and KMS. And let's add some more boxes into this page. And if we want to introduce some third-party services to play together on the stage, the diagram can be like this. There are a few key points. The first one is non-CC workloads can still use the KBS protocol to access the resources as long as they meet the policies. So the same broker can serve both CC and non-CC workloads using attestation where available and other claims when needed. And the point two is Trustee can broker resource accessed by URI. That might include Kubernetes-based secrets encrypted in etcd or other URI addressable resources. And the point three is Trustee can directly call third-party attestation services, for example, ITA. The point four is Trustee can call third-party verifier to verify specific TE evidence, for example, NRAS for NVIDIA, and Verizon for ARM-CCE, and others. This is where the collaboration with CCC rarely shows up. Trustee leverages Verizon's verification capabilities by calling it as a service. And this design can let us integrate with Verizon and other verifiers rather than replace them, and provide a common consumption layer for relying parties and workloads. So let's see the next page.
I think there's a question for Mark on the call. I don't know if we'll take it now.
Yeah, and hang on just a sec,
if you
Mark,
don't, if you don't mind, if you're going to go into it later, then I'll wait. But so you sort of the key concept here is a resource or a key, right? So you can basically go to a key broker service and get back a resource or a key. I do not understand. You also mentioned in the very beginning that you're going to somehow align this with Whimsy, and under Whimsy, what you request is a credential, right? So it's a little bit unclear to me how you make it Whimsy compatible. Have you actually prototyped this, investigated this?
So we've got that a few slides ahead.
Okay, now wait.
And then, Keith, to your earlier question, I don't know if this kind of helps illustrate the utility of the key broker service a little bit better. But any workload like a Cocoa container that's configured to work with the key broker service, if you decide that you want to use ITA instead of the trustee attestation service, you don't have to make any changes on the left hand of the diagram. Or you get a new verifier in place for a new architecture that all just goes on the back end and you don't have to affect the workload. Sort of similarly with those different resource providers that depend on this, like etcd there. So you can have that configured with your normal Kubernetes distribution, or what we'll get to in a few slides with Mark's question about getting a workload ID. Benny?
Yeah, thank you. I also have a question about etcd because you just mentioned that here. Because how could the key broker service, or where is the key broker service deployed when it accesses it? Because assuming you just deploy the key broker service in your regular Kubernetes cluster, that's not good, right? Because it has to be protected. It's very sensitive and so on.
Yeah, that's a great question, and I think we could use some diagrams for that. But one deployment model you might choose is that your container infrastructure is in a CSP, and you operate the key broker service on-prem in your own data center. So it is.
It still could connect to etcd to get the secrets out.
Right. So you would need the right network relay in place to be able to do that. But the idea is that the resources. So one specific use case is you can use Kubernetes secrets in etcd. So normally those are effectively clear text. And we don't want the Kubernetes administrator to be able to read those. So instead we put them in an encrypted form in etcd. And then the KBS helps deliver a key so that you can decrypt that locally within the container.
Okay, thank you.
Yeah. Okay. So, sorry. So I can't see the raising hand. So please interrupt me and please interrupt me at any time if you have any questions. Thank you. Okay, let's go ahead. Let's see where we are. And we just finished the deployment versatility, and let's see we will get to the workload identity topic. So let's see the architecture again, and we will add some more boxes onto the page. And I want to connect trustee to a workload identity discussion in the CCC workload identity seek. And the core problem we are looking at is in the confidential computing. How do we give workloads a stable identity? And when what we actually trust are very low-level measurements like container hash and T registers. And on this slide, I'm focusing on what we already have to work with. If you look on the left, inside the CVM, we have a container running and a attestation agent. And that agent can see and report a container hash. The hash is very strong, but also very brittle identifier. And we can also include host data for SMP, configuration IDs for TDX, and personalization data for ARM-CCA in the attestation. Those are shown along the bottom. And on the right, we still have our attestation service and RVPS, which verify the evidence and produce an attestation result driven by attestation policies. And in the middle, the KBS now has the extra function, claims mapper policy. And the idea is that KBS can consume attestation results from the attestation service, and plus all those low-level claims, container hash, host data, config IDs, and then apply a claim mapper policy to turn that into a higher level workload identity. And that workload identity could then be handled to something like a Spire server and expressed as a SVID or another long-lived identity. And let's walk through an end-to-end example of how this could work in practice. And step first, we start by creating a CVM with an expected container hash or some hosted data or config ID or personalization, and to initialize the CVM. And step two, inside the CVM, the agent enforces the container hash in the host data, config ID, personalization matches the running container. For Coco, the agent is named cut agent. And step three, when the CVM attests to the KBS, the evidence includes host data like AB123 and runtime measurements like RTMR2 equals to AB123. And step four, the attestation service verifies the evidence using its policies and reference values from RVPS and produce a attestation result. We support to add some extra information along with the attestation result extracted from the whole evidence. And this extra information is called validated identifiers. For example, the container hash, the init data. The init data is an abstraction for the host data for SMP, config ID for TDX, and personalization field for CCA. So then the step 5, the attestation result and the validated identifier flow into KBS where the claims mapper policy runs. And that policy maps a container hash plus init data plus whatever other claims we care about to a specific workload identity. Essentially, that means this is a service X and obviously this is a workload Y. And the last step, the workload identity is certified, for example, as a SVID for the workload. So downstream systems don't have to deal with the RTMRs or the attestations or the container hash. They just see a normal SPIFFE ID or similar identifier. And this identity represents the workload. So this page, let's talk about the KBS protocol. And this is the attestation protocol that trustee uses. And this protocol has two phases. And the first one is authenticate. The client and the KBS perform what we call an RCAR handshake. It's basically a challenge response style protocol. And at the end of this handshake, the client gets either an attestation token or a session cookie. This token or cookie encapsulates the attestation result and the trust decision at that point in time. And the stage 2 is request a resource. The client then presents the token or cookie. It requests a resource by URI. The KBS checks the token, evaluates the resource policies, and if everything passes, it returns the resource. So this design is first TE agnostic. The protocol doesn't hardcode Intel or AMD or ARM in the protocol, and it is cloud agnostic. Different clouds can plug their own verifier services behind the KBS, and it's also usable by non-CC workloads that can authenticate in other ways. And this picture shows a detailed process of the protocol. And I think we are not going to dive too deep into the cryptography design, but on the left we can see the RCAR messages body format, and it provides a anti-reply attack security. And on the right, it is a resource access process. And all the resource get from the KBS will be encrypted in GW format with the T pub key inside of the attester. And finally, a quick look at what's coming next. And today, Trusty is typically deployed as a regular service, often in a secure environment, but not necessarily in a TE of its own. We are working towards as a deployment mode where Trusty itself runs inside a TE or enclave, establishing its own root of trust. This would allow stronger security for the KBS and the taxation service. And stronger guarantees to clients that the broker itself hasn't been tampered with. This is another area where we're very interested in is how should a trusted broker service be attested? How should the trustee in TE communicate its own trustworthiness to clients? And to wrap up, Trustee provides a general purpose attestation verifier and broker for Reliant Party services, and it already integrates with Verizon for CCE, and we can call other verifier services like IT and NRAS. And it can help implement the claims mapper and workload identity ideas from CCC or WIMC. The KBS protocol gives us a simple TE agnostic way for workloads to use attestation to obtain keys and other resources. And we are not trying to replacing existing verifier services. We want to sit on top of them and make them easier to consume in real-world deployments. And hopefully, we can work together to make the KBS protocol a standard. And we think we can first reduce duplication for everyone. The second, increase interoperability across clouds and TEs. And third, create a solid shared foundation for confidential workloads. And last one, so there are any questions? And I'm very happy to hear about your questions. Thanks, folks.
Thank you, Ding.
Thanks.
Renee?
A great presentation. Thanks, Ding. Two questions. You mentioned support for third-party attestation services like ITA. Of course, there's MAA from Microsoft, GCA from Google, and others. How easy it is to support those other third-party attestation services?
Yeah, we have a common interface definition in the KBS repository. It overall it looks like receives the T evidence and the evidence type and returns GWT token. That's the interface required to do. So if you want to integrate some more third-party attesting services, you just need to implement a simple client that has those abilities.
Got it. And then as far as consuming reference values or making those available, is there now kind of easy standard or way to do that for, say, cloud service providers?
Sorry, my English hearing is not good. So can you
So Renee, were you asking for the remote value
Yeah.
value providers?
Yeah, how easy it is to make reference values available in this model to this RVPS, or is it like a separate plugin as NRAS is shown here in Verizon?
Yeah, look, I can take this one, I guess. So the RVPS is quite modular. All of Trusty is quite modular, which actually goes to your last question as well. And depending on exactly what your requirements are, there's different places to plug in. But the RVPS has an extractor interface where you can implement different code that can like read from some kind of like reference value manifest and then put it into the RVPS language, and then that will very smoothly go into the policies that the attestation service needs. Currently, we don't have as many extractor modules as I would like, so we should be adding some more. But generally speaking, if you have some format of reference values, it's pretty easy to get those into Trusty. And we also have thought a fair amount about like the different roles here. So if you have one part of your enterprise that's going to be providing the reference values, and then someone else is going to be operating Trusty or something like that, how do you reconcile this? And there's also some thinking that's been going on about how do you then reflect those reference values in the attestation report as well, because obviously what the reference values are may determine the validity of the guest. So it's important to sort of reflect that. But do you want to put all of that information into the attestation token? Well, maybe not. So anyway, there's some thinking about that too. And there's some evolution that still needs to happen with the RVPS. But yeah, I think the short answer to your question is yes. Or possibly no. I forget exactly, but
I think, for example, we have co-RIMs going in right now from some providers. So I think that's an example of something that's fairly standardized.
Great.
Were there things that what kind of reference values were you thinking of, Renee?
Yeah, I mean, this whole model hinges obviously on providing and having up-to-date reference values, right? And obviously that's a pretty complex flow for especially cloud service providers with staying up to date and security fixes and things like that. So just complex workflow that I don't think anyone has fully figured out.
Great. Hank?
Yeah, as an additional comment, I think my camera is off. So as an additional comment, yeah, CoRIM, you already said that then, I think is a suitable candidate. There is an old school one defined by TCG, and currently an IETF, a more versatile next version is hopefully finalized, I want to say. Yeah, and as with the, I want to say, regulation SBOM issue, quorums would have to be created alongside the software supply chain somehow, at least from authority to authority, then handed over. And yeah, so this is basically quorum is intended to take into account multiple requirements that keep the verifier load and policy complexity low. And yeah, so therefore, there's no real great alternative out there. But certainly you could fall back to yet another EAT usage, the entity attestation token. But then again, you would have to define the whole semantics yet again. So I assume without some redundancy today, it's mostly quorum.
Yeah, I should also clarify that today we don't have a quorum extractor. That's to do. We want to add that. We have a TCG RIM IM extractor that's not fully like spec compliant, but it works. In practice, a lot of people, we also just have a way you can just tell, hey, here's the reference values. And we have one other I'm forgetting or whatever. So, and there are a lot of subtleties here in terms of like, do you want a pull model? Do you want a push model? How do you handle caching? Things like this. There's definitely plenty of work to do here. But the RVPS we have a pretty good start on this, I think.
Yeah, so that's the HIRS endeavor from the US government. And please don't ask me what that acronym means right now. I know that's a repository name. And so that uses the TCG RIM specification, but that also involves, there's a component RIM now, and it's all based on the SWID or co-SWID specifications. So it is a little bit tailored towards the TPM world. So if you want to have more of a broad stroke for reference values, for example, with nested layering that is in support of dice, which is also TCG, but a little bit different than the TPM evidence, or from the platforms itself, like the AMD SEB attestation report and such, then I think Quorum becomes the more interesting option. But yeah, there is, I want to say, for especially TPM space, there's the TCG RIM and concise RIM specifications and the component parts as well.
Great. Maybe just a couple more minutes for questions, and maybe I'll try to put Ming Shen on the spot. I was just kind of looking through the attendee list here and thinking, what projects do we have represented that might think about an integration point here? And so for Manatee, I don't know how Manatee is handling attestation verification, or if you already have a solution for this, or whether potentially integrating with Trustee and the KBS would be helpful to Manatee or other projects that you have going on.
Yeah, Manatee is using confidential space, so essentially it is using Google's attestation service. So Trustee is not you cannot integrate the Trustee with Manatee for now. For other project, what we are experimenting internally is the trustless attestation service, the zero trust attestation.
Okay.
Yeah, we are trying to launch Verison and Trustee internally using zero trust proof. So I think this is what we are experimenting.
Great. Okay, thanks for that. Paul, I think I saw your hand up.
I think he was going
to. Yeah. Sorry. So I would I think my comment is past relevance now. But there was a question about like caching for reference values and selection languages and pull versus push models and that kind of stuff. So I wanted to point out the CoServe work, which we're doing alongside CoRIM in the IETF working group as well. Definitely worth looking at that if you're looking for like query languages and selector APIs and standard behavior. That's a piece of work that we have in flight. And I tried to post a link in the chat, but actually I've posted an old draft because it's an adopted one now. So I need to just update the link, which I'll do in a second. Sorry.
We're looking into CoServe. We'd like to support that.
There we go. Thanks, Tobin. Yes, I've just updated the chat with the better link.
Thank you. That was still relevant. I'm glad we got that out.
Yeah, we are tracking this work.
Okay, well, great. Well, I think we should continue to look for opportunities to integrate with CCC projects. And for those of you out there that don't have a CCC project, but you're obviously working on confidential computing, maybe with proprietary projects, also happy to help connect people for integrations with that.
Yeah, before we go to the next topic, let me just mention that if people are interested in this, you can go to the confidential containers. Go to the cloud, the CNCF Slack workspace. There's a Coco Trustee channel, and that is a very good place to have like synchronous conversation about this. Of course, we also have the repo make an issue. If you're curious, just like, oh, I don't know, like if you just want to know, like, hey, I have this service or this project, and I'm just curious if it's going to be easy to like use this thing or what it would even mean, just drop us a line somewhere, and we can sort that out and think about it some. And yeah, we'd like to add adapters and support for every single attestation thing out there. So if you have one, let us know and we can talk about it.
Okay, great. Thanks. Before we lose people, I also wanted to say thanks to Yash for being an excellent vice chair in 2025. Most of you aren't exposed to the work that goes into setting up and following up from meetings and trying to drive agendas. And it was great having Yash around to help with that work. Certainly miss his help in 2026. And another thing that Yash did for us was really focus on that mentor program that we have to help bring new contributors into the community. And we saw a lot of good traction, especially with the Verizon project. And that's all due in good part to Yash and the collaboration with Rian and Verizon and the rest of you who contributed there. So thank you, Yash.
Thank you, Dan.
Hank,
yeah, that's a new hand. Just a quick shout out to Ding and Tobin. So if you're really considering going the standardization route, just shoot me an email and we can check the scope and which parts might be suitable to do that. Maybe there are some reusable building blocks that already are relatively interoperable. So if you're interested in following that route, actually just ping me.
Great. And I think sort of a path to standardization is also adoption. So the more companies we have that try out this protocol and help shake loose any issues with it, the more it's sort of a de facto standard through just the utility of it being adopted by multiple companies, multiple projects. All right, so we've got like 60 seconds left. We're not going to get into these topics, but to Keith's earlier question about where to get these links, I also usually send these days in advance on the mail list. And so I think those are all in the thread where we talk about the agenda. That's kind of where I pasted them in for the slides. So you all have that. Again, it's our last meeting, but I'm hoping we can still make some progress on these asynchronously over the next couple weeks here. But until we speak again, thanks for everybody's contributions in 2025. Looking forward